Good. So we're just recapping since we took some time off to do some refactoring. We're just kind of doing a quick recap of the book. Probably this week and next week, we'll just recap the first 4 chapters, and then we'll start off on chapter 5 in 2 weeks from now. Yeah. And then
which book is that again?
It is Sandi Metz's Practical Object-Oriented Design in Ruby.
Oh.
It is, looks like this here, that book there.
Oh. I'm not sure if I have a copy. I'll check. Let me check.
Okay. So yeah, so sorry for those watching the broadcast. I forgot to start it, but we're just recapping chapter 1, so you can easily read chapter 1 if you're interested in that. I just took some notes. So we're talking about, creating design. So you have 2 tools as a developer. So there is a decision to make every time you write code. And I feel that a lot. Every time I sit down to write code, I have decisions to make. However, fortunately, there are a lot of people before us that had to make these same decisions, more or less, and they've come up with principles and patterns that are proven to create good code. And they have been proven. There's been dissertations written about them, and most importantly of all, they've been time tested. They've been, they've survived the test of time, and they've been used in real world applications. So these principles and patterns are your tools. And just like any tool, they can be misused. And the only way to really learn how to effectively use your tool is to use it, every day. At first you may not be good with it, but with practice and time, and you'll gain experience, and you'll evolve into a better programmer over time. So the first tool, design principles, this is like solid. We got single responsibility, open closed. I forget what that is. We'll get to it. The Liskov substitution, interface segregation, dependency inversion. And then other principles include dry, don't repeat yourself, and law of Demeter. And coincidentally, if you follow these solid rules, then these pretty much naturally arise too. And then the design patterns. This book pretty much straight out says, this book is not about patterns, but it says the design patterns. So there is a book that was written, and it's called Design Patterns. It was written about 20 years ago or something. But so it describes patterns as simple and elegant solutions to specific problems in object-oriented software design that you can use to make your own designs more flexible, modular, reusable, and understandable. So every tool in your arsenal can be used for something it was not meant for, which will ultimately cause more problems and pain. However, if used correctly, then the resulting product will be an art beauty. So yeah, I kind of said that already. So then, this book is not about patterns. However, it will prepare you to understand them and give you the knowledge to choose and use them appropriately. And so that is like very important right there, right? To be able to understand the patterns, to recognize them, and to have the knowledge to choose which pattern to use and when to use it and where to use it, right? So that's, that's great, because you know, a lot of people, you know, when they're first starting off or when they're first learning about this stuff, you know, say, oh, we can do this and can design it this way and do this pattern. And, you know, what if they need to do this later on? And they start, you know, doing all this work, and yet they're just making it more complicated and putting in designs and patterns where they don't necessarily belong. And that's so the act of design is, you know, having the tools and knowing what the product should look like will not grant you access to being a master crafter. That only comes with experience. You must practice your craft every day so that tools become an extension of you. So there's ways that design can fail. Lack of design obviously causes design failures. You know, when we're all first learning how to program, writing hello world, and we go on to bigger and better things, we don't yet know about design. So, you know, we don't have the experience to know about design yet. And so this is kind of true for like novice developers, right? The programs lack design. So if you hear yourself saying, yes, I can add that feature, but everything will break, then, you know, you know that there's kind of lack of design in the application. And so this is where experience comes in, right? So nobody starts off designing good code, something that must be practiced, something that is learned. So the second way that design fails is that as you get more experience, you know, more experienced programmers, you know, they become aware of design techniques, but do not yet know how to apply them. So products tend to get over-designed in this case. And you can recognize this when you hear something like, no, I can't add that feature. It was not designed to do that. Right. So, and then the third way how design can fail is object-oriented software fails when the act of design is separated from the act of programming. So design is a process of progressive discovery that relies on a feedback loop, like the agile software movement, right? So the iterative nature of agile development allows design to adjust regularly and to evolve naturally. You know, the constant feedback that you get from the clients. When design is dictated from afar, none of the necessary adjustments can occur, and early failures of understanding get cemented into the code. That's like, you know, maybe 30, 40 years ago, a lot of companies, they said, oh, we need to design everything before we write any code. So they design the whole system, they write all the code, and then the client comes back, oh, we need to change this. And they're like, well, no, we can't do that. We didn't design it to do that, right? So it's like they call that the big upfront design. It's like kind of like the waterfall software delivery life cycle, something like that. But so now with Agile, doing like more of Agile, where you got a constant feedback loop, it allows you to allows the design of the application to evolve into something that can easily be changed, hopefully. So you can recognize this when you hear yourself saying, well, I can certainly write this, but it's not what you really want, and you will eventually be sorry. So that's when you're designing for something that may not be needed, like doing the big upfront designs. So when to design? So the Agile software movement believes in small iterations so that there's a continuous feedback loop from the customer to the developer. Usually people do not know what they want until they see it, hence the small iterations. So one thing's for sure, change is inevitable. This allows software to be developed that could not have been anticipated by other means. So basically saying, just because big upfront, like doing a bunch of design in the beginning is not good, they're not saying don't do design. They're just saying do design, but do small iterations of it. Applications need design. So if this is true, then there is no point in doing big upfront designs. Big upfront design is completely documenting and specifying all the inner workings of all the features proposed for the application. So Agile does not prohibit design, it requires it, just not all at once. So this is supposed to say judging design. So they got metrics. They got software metrics that you can run against your source code. That'll kind of give you a score, like, oh, you get a high score. It's telling you that your code's probably not designed well. You get a low score. It's supposed to mean that your code is designed very well. You kind of use your. You got to kind of take those metrics with a grain of salt. If you get a high score, you're most likely, yes, there's probably some design failures in the code. But if you get a very low score, it doesn't mean that your code's great. You could have put in everything you learned about design and patterns into your code, but put them into the wrong places, so that when you go back to it later and need to make changes, it's going to be difficult. So you got to kind of take the metric, the software metric, with a grain of salt. So use them, but don't, depend on them. Still use your best judgment. And then it had a subsection in chapter 1 about a brief introduction to object-oriented programming. And within that, it talked about procedural language and object-oriented languages. I highly suggest just to probably, if you're going to reread anything from chapter 1, I would suggest reading this section here. So yeah, I'm not going to cover it because the book goes into a lot of detail about it that I just can't cover in some notes. It's really good just to reread it. And then I started to read chapter 2 again. So chapter 2, designing classes. So chapter 2 is about designing classes with single responsibility. And that is our first principle in our principle 2 bag, right? In our tool bag, it's one of our first principles, single responsibility. So the chapter focuses on what belongs in a class. What are classes? So it kind of covers all these questions throughout the chapter, like what are classes? How many should you have? What behavior will they implement? How much do they know about other classes? How much of themselves should they expose? So generally, we group methods into a class. So we organize code into methods. And, it talks about, don't worry about getting it correct today, because you're most likely not going to get it correct today because code changes, clients change their mind. And then obviously the requirements become more clear as the time progresses. So yeah, the more you work with the code, the more you understand it. And so design is more about the art of preserving changeability than it is the act of achieving perfection. Yeah, so every time you write code, it's never perfect, right? you're always going to go back and change it, is what it's saying. So it's not about perfecting it today. It's just about allowing it to be changeable in the future.
So mi nimekuwa na vituko leo.
Okay, what's happened?
Si vituko mbaya sana.
Hey, Sita. So organizing code to allow for easy changes. So defining easy to change. So so what is the definition of easy to change? Changes, so when you make a change, they have no unexpected side effects. Small changes in requirements require correspondingly small changes in code. And existing code is easy to reuse. The easiest way to make a change is to add code that in itself is easy to change. So the code should then have the following qualities, which is transparent, reasonable, usable, and exemplary. And that kind of gives it an acronym TRUE. So the first step in creating code that is true is to ensure that each class has a single, well-defined responsibility, which is what chapter 2 is about. So let's so transparent here. So transparent basically means the consequences of change should be obvious in the code that is changing and in distant code that relies upon it. So when you write code, you can look at it and you know exactly what it's supposed to do. Reasonable. The cost of any change should be proportional to the benefits the change achieves. Usable. Existing code should be usable in new and unexpected contexts. And then exemplary. The code itself should encourage those who change it to perpetuate these qualities. So let's talk about classes, creating classes that have single responsibility. So get into some fun stuff here. So a class should do the smallest possible useful thing. That is, it should have a single responsibility. Right? So it gets into our example application that we've been building. So bicycles and gears. So we created the gear class from the example in this book. Let's take a look at it. So it talks about chain rings, cogs, and ratios. I'm not going to cover all that again, but let's pretend that we have a request. So the application will be made of Ruby classes, each representing some part of the domain. Let's see. So I guess this is the request. Believe it or not, there are people who care deeply about bicycle gearing. You can help them out by writing a Ruby application to calculate gear ratios. So we're going to write an application that calculates gear ratios. So then if we read through this description, we'll see two nouns there. The nouns are bicycle and gear. These nouns represent the simplest candidates to be classes. Since, we're working with bicycles, intuition says that bicycle should be a class, but there's nothing in the above description here that lists any behavior for bicycle. So as yet, it does not qualify. However, gear, however, has, it's got these ratios, which consists of chain rings, cogs, and ratios. So it has both data and behavior, so it deserves to be a class. So So we can create the gear class, and this is what it looks like. We got class gear, give it an attribute reader, chainring cog, initialize it. And then we got one method, ratio, like the gear ratio. It calculates the gear ratio. Takes the chain ring and divides it by cog. And we could implement it this way, gear.new 5211.ratio. So after we implemented that code, the client comes back and requests a change. They want to be able to accommodate different wheel sizes. I'm like, okay, we can make that change. So, yep, she would like to also calculate the effect of difference in wheels. All right. So we go in, we make that change. Now we need rim, tire, right? And we initialize those. Our ratio method does not change, it's still the same. Now we calculate gear inches. So then we take the ratio, then we multiply it by rim plus tire times 2. This is just a formula for diameter of the wheel. So the ratio times the diameter. And now we can implement it this way. Puts gear.new 521126.5.gear inches. The only problem with this is that it now broke our previous implementation where we were doing puts gear.new 5211. Here, this expects 2 parameters, gear to have 2 parameters. But this one requires gear to have 4 parameters. So it already broke our code that we just wrote. Really isn't a big problem since this is so small and there's only one class. We can change it, that's fine. So yeah, so here upon implementing the change, we saw that altering the number of arguments that a method requires breaks all existing callers to the method. So the first code we wrote did not accommodate change that well. As soon as we implemented one small change, it broke everything else. So, and we saw a way around that. You know, it talks about how to fix this in the future so that this change wouldn't break everything else, and we'll get to that. So determining if a class has a single responsibility. So let's check out the code and see if it has a single responsibility. So does this code have a single responsibility?
Yeah, I think so.
Okay. So let's see. Okay. Yeah. Why do you say it has single responsibility?
Because it's not depending on another object, and also all the things, the ratio and the gear inches are something that belong to gear class.
Mm-hmm.
Yeah.
Okay. What about rim and tire? Do they belong to gear class?
Actually, no.
So I think your answer is correct-ish, right? I mean, yeah, it does have, more or less has a single responsibility. You're right, chainring, cog, all belongs in this class. Gear inches, yeah, gear inches sort of kind of belongs in this class according to the book. And gear inches does need rim and tire. So there's not really a correct answer here. You can argue that everything does belong in here, and you can argue that it doesn't, right? So it all depends on people's perspectives, I guess. But let's see what this has to say. So yeah, so single responsibility requires that a class be cohesive, that everything the class does be highly related to its purpose. So if we say that, okay, no, it doesn't have a single responsibility, should we change any of it? Again, that's like highly debatable, right? We could make an argument that yes, we need to change it, or we can also make an argument of no, that it doesn't need to be changed because we don't have enough information. So, and they're both valid. You could say, oh, we need to change it. It doesn't have a single responsibility. We need to extract rim and tire from here and put it in its own class and into the wheel class. But at the same time, we could make the argument that, we don't really have quite all the information that we need to do that yet. Let's wait until we get more information and do that. And so that's why, there's always this tension in code. And this is why code is never perfect, right? This code is not perfect, but it could be perfect for today. But next week, it may need to be changed. So applications are never perfectly designed. This improve it now versus improve it later tension always exists. So one of the things that's going to talk here is depend on behavior, not data. And that comes, so we kind of, covered what our class is, right? So we created a gear class. We didn't create the bicycle class because it didn't have any, at that instance in time, there was nothing for the bicycle class to do. So, so here we're going to talk about like how much do they know about other classes, how much of themselves, yeah, this is what we're going to talk about. How much of themselves should they expose? So depend on behavior, not data. So always wrap instance variables in accessor methods like this. This is an accessor method. We can read these instance variables. This changes data that is referenced all over to behavior that is defined once. And for example, we can take a look at this code here. Yeah, so here we can, I'll go back a little bit because this is a good highlight. So determining if a class has single responsibility. If you rephrase every one of its methods as a question, asking the question ought to make sense. For example, please, Mr. Gear, what is your ratio? Seems reasonable, for a gear class. Well, please, Mr. Gear, what are your gear inches? It says that it's on shaky ground. And then, please, Mr. Gear, what is your tire size? That just doesn't really sound right. Why would gear have a tire size? Then you can also, if you can describe the class in one sentence, then you can, that's another way you can try to figure out if the class has a single responsibility. If you end up with words like and, then the class has more than one responsibility. If you end up using the word or while you're trying to describe the gear class, then the class has more than one responsibility and they're not related. So yeah, let's get to this method here. So here we go. Let's see. So hiding instance variables. So yeah, here the instance variables are not hidden. We have to refer to the instance variable at chainring at cog. This may be fine for today, but in the future, if you ever have to do something like so yeah, it says to do, use attributes readers to access them. Then you don't have to use the at, so you don't have to refer to the instance variable. You can use the defined attribute method. Let's see, it's got another example. So this is what it gives you when you use the attribute reader. It automatically gives you this method, definition cog. It just returns at cog end. So now, this cog method is now only in one place in the code. And so if you ever have to change how you return cog, you can just change that one method and it takes care of it wherever you reference cog at. So for example, you have to do something like return at cog times bar adjustment if there's foo, or if there's not foo, then multiply it by some other adjustment. Then if you ever have to do that to cog, then you only need to do it in one place. So it changes data into behavior when you use the accessor methods. So they're good to use, they're free. So yeah, this talks more about that. Here we go. So hiding data structures. So let's take a look at this code. So yeah. So here we got some code. We got an attribute reader data, which is initialized. Okay, so far so good. Then we got one method. It's called diameters. And so we take data and then we map it. So we'll collect it. So basically we're going to get a new array back. And in that array, so we're iterating through each cell of the array, and so it's a two-dimensional array, right? So we got a two-dimensional array that we take in as data. Then for each cell, we take the first element and add it to the first element times 2, and we return that into a single dimension array of diameters. This, if anyone were to look at this, they'd be like, what is this doing? I see a method diameters, but I have no idea what this is doing, right? So how can we fix this? And fix it by, so we got an external two-dimensional, so we've got, maybe we're calling an API, and it's just giving us this two-dimensional array that we have to do something with, right? We do not control what that API sends us. We just know it's going to send us a two-dimensional array that we can use to calculate diameters. We don't want our code to look like this, so we want our code to be easily understood. So here's an example of the two-dimensional array it gives us. So we could change it to look like this, right? So we get our data in, we initialize it. Instead of passing it to diameters, we can say, well, this is really just data about wheels, right? So the first element in the array is a rim, and then it's a tire, so then we can calculate the diameter. So then we can take that external two-dimensional data that we get from our API call, and we can turn it into something here. We can wheelify it and turn it into something that's much more readable. So here, when we look at the diameters method, we got wheels.collect, and then for each wheel, we're going to take the wheel.rim, and we'll add it to the wheel.tire, multiply by 2. So basically the formula for that diameter. And we get an array of diameters back. And they did that by doing, creating, this basically creates a little miniature class, right? We got struct.new, so it creates a wheel class that's got a rim and a tire. And then we can put in where we take the data, then we can do data.collect cell. This basically, for cell 0 and cell 1, we call wheel.new. And so wheel.new, cell 0 gets applied to rim, cell 1 gets applied to tire. So we know cell 0 is rim, cell 1 is tire. And then we can just call the names here. So this struct gives us, struct is a convenient way to bundle a number of attributes together using accessor methods without having to write an explicit class. So it's a good way if you can't really justify creating a whole new class, you can create a struct to kind of wrap around this external data that you're getting to make it more readable. So if we look at the diameters method here, so just like classes, methods should also have a single responsibility. I think it comes too big. Let's see. Yeah, so if we look at the diameters method of class, this method clearly has 2 responsibilities. It iterates over the wheel and calculates the diameter of each. So we can simplify it by separating the code into 2 methods. So now when we call diameters, we got wheels.collect, and then for each wheel, we calculate the diameter of wheel. And then we got a method diameter that just takes wheel.rim plus that. So this is even more readable now, right? And then it says, will you ever need to get the diameter of just one wheel? And it says, look at the code, you already do. This refactoring is not a case of over-design. It merely reorganizes code that is currently in use. So the fact that the singular diameter method can now be called from other places is a free and happy side effect. So if we take a look at the gear inches method, we can actually, this is what we're doing in the diameter method, right? So we can actually just put times diameter here. So separating iteration from the action that's being performed on each element is a common case of multiple responsibility that is easy to recognize. So now we can update the gear method to say, ratio times diameter, and then the diameter is that calculation there. And now this simple refactoring makes the problem obvious. Gear is definitely responsible for calculating gear inches, but gear should not be calculating wheel diameter. So it talks about, when you refactor code to have a single responsibility, it kind of could reveal stuff to you that you wouldn't have seen before. So in this case, it kind of revealed to us that our gear class should not be responsible for doing this calculation, should not be responsible for calculating a diameter of a wheel. Yes, and then so methods that have a single responsibility convey the following benefits. They expose previously hidden qualities, they avoid the need for comments, encourage reuse, and are easy to move to another class. And so then, so isolate extra responsibilities in classes. So your goal is to preserve single responsibility in gear while making the fewest design commitments possible. Because once you start making design commitments, you kind of fall back on what this was saying earlier. We might be over designing something, right? So you want to make the fewest design commitments, until you have all the information you need to actually commit to something, right? So, go away. So because you're writing changeable code, you are best served by postponing decisions until you're absolutely forced to make them. Any decision you make in advance of an explicit requirement is just a guess. Don't decide. Preserve your ability to make a decision later. Let's see. Let's take a look at this code. So here we have attribute reader, chain ring, cog, wheel. We got initializer, which takes in chain ring, cog, rim, tire. And then and we create a wheel object within gear. And then so basically, and then the same thing we had before. You calculate the ratio, and calculate gear inches. And then we're using this struct to create a wheel class. And then we can calculate the and then it also has behavior within this miniature class, and it's got a diameter. So let's see. So Ruby allows you to remove the responsibility for calculating tire diameter from gear without committing to a new class. So that's what we saw. Use the struct. So the following example extends the previous wheel struct with a block that adds a method to calculate diameter. So we were able to make a little bit of a design change without actually committing to a whole new class. Now you have a wheel that can calculate its own diameter. Embedding this wheel in gear is obviously not the long-term design goal. It's more an experiment in code organization. It cleans up gear but defers the decision about wheel. So by doing that, it suggests that you expect that a wheel will only exist in the context of gear. Common sense would suggest otherwise, but in this case, there's not enough information exists right now to support the creation of an independent wheel class. This is supposed to say not enough information. I don't know. But anyways, or maybe, yeah, in this case. Or perhaps it's saying, yeah, enough information exists right now to support an independent wheel class. However, every domain is different. So then you finally implement the real wheel, right? So while you're pondering the design of the gear class, the feature arrives, you show your calculator to your cyclist friend again, and she tells you that it's very nice, but while you're writing calculators, she would also like to have one for bicycle wheel circumference. So she has a computer on her bike that calculates speed. This computer has to be configured with bicycle wheel circumference to do its job. So this is the information we've been waiting for. It's a new feature request that supplies the exact information you need to make the next design decision. So with that new design decision, we can now move wheel into its own class. Gear pretty much stays the same. And then here we create the new wheel class. It still has diameter, and now it's got circumference. So and then we can use it like that. So, ooh, what did I do? All right. So yeah, and that's the end of chapter 2. So now both it says both classes have a responsibility. The code is not perfect, but in some ways it achieves a higher standard. It is good enough. Like, you know, like Sandi will probably say, oh, like Sandi had said, you know, code is never perfect, right? This is not perfect, but it is good enough for today. And that puts us at the end of chapter 2 and about the end of 1 hour. So next week, I will try to recap. No, I will recap chapter 3 and chapter 4 for us. Let's see. What's the summary say? So the summary, the path to changeable and maintainable object-oriented software begins with classes that have a single responsibility. Classes that do one thing isolate that thing from the rest of your application. This isolation allows change without consequence and reuse without duplication. And that's very powerful, right? So if we can isolate that one thing from the rest of your application, then that isolation allows you to make changes without consequences, and you can reuse that isolate. You can reuse whatever you isolated without having to duplicate anything. So that's why, you know, if you can really implement single responsibility everywhere in your code, then it, you know, it's a huge improvement even if you do nothing else. So chapter 3. So next week, quickly go over chapter 3, managing dependencies, and then the creating flexible APIs in chapter 4. And then after that, we'll get back on track. We'll dive into chapter 5. I believe, yes, we'll do a lot more coding. So yeah, so then we'll start coding in chapter 5. It's a looks like a kind of long chapter, so I might spend like 2 weeks, maybe 3 on that chapter. But yeah, so next week we'll recap real quickly, and then chapter 5, a week after that, we'll get into chapter 5 and start doing more coding exercises and all that. Sound good?
Yep.
All right.
That was great, Nick.
It went quick?
I said that was great.
Oh, cool. I'm glad.
Recap.
Tried.
We was quiet, but we was.
Oh, good. Yeah, I didn't know if you all were gone or not.
We're here.
Yeah, quite audience.
Yeah.
So,
Quite.
so yeah, I kind of like rereading the book, but
Yeah, this book is like awesome. Every time you
yeah,
read it, you find something that you missed it before.
yeah, exactly. I agree.
And it always makes sense at the time you're reading it because you remember some of the cut that you was playing, working on 2 hours ago or
Yep.
before,
Yeah.
and you see that maybe I could have improved this thing
Yep.
if I did this. Yeah, that's very 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 powerful.
Yeah, I agree. 100%. Cool.
Yeah, I was working extracting something to a gem, and yeah, these things sounds the single responsibility thing is powerful if you can use it as
Yeah, I
yeah
agree. And sometimes
well
it's kind of difficult to figure
yeah
out how to do that, right?
yes
So,
exactly.
yeah.
Sounds good. So
Alrighty. Cool beans. Well, yeah, thanks for joining. And yeah, we'll get through the next 2 chapters next week and then get back on track.
okay, see you
Okay.
Alrighty.
next week.
Oh, thank you.
Bye.
Bye.
Bye, guys.